So I'm going to do problem number 7 in chapter 8, which says, two objects are connected by a light string passing over a light frictionless pulley as shown in figure P8.7. The object of mass 5 kilograms is released from rest using the isolated system model. A, determine the speed of the 3 kilogram object just as the 5 kilogram object hits the ground, and B, find the maximum height to which the 3 kilogram object rises. So, started off by drawing the picture. So like the picture is actually shown in the book, so it's pretty easy. You have mass 1, which is 5 kilograms at the top, mass 3, which is on the ground, which is at height equals 0. The mass 1 is 4 meters above the ground, and so on. So I started by summing up my forces. So forces on block 1 are tension, which is upwards, and then mg, which is downwards, which equals mass times acceleration, and the force on 2, which is tension, which is the same as the tension on 1, because it's the same string, minus mg equals ma. And then I plugged in the given variables for those. So tension equals 49 newtons, because 5 times 9.8, plus 5 kilograms times acceleration, because you don't know acceleration. So I isolated t, and then I plugged in our givens for this one, and then I plugged in this, summed up forces, solved for t, I plugged in for t, into our second force equation, got 49 newtons minus 5 kilograms times acceleration minus 3 kilograms times 9.8 meters per second squared equals 3 kilograms times acceleration. So I put both parts of the equation that have A on the same side, and then ended up with 19.6 joules equals A times 8 kilograms, which gives us an acceleration of 2.45 meters per second squared. And then from there, I plugged into the kinematic of Vf squared equals Vi squared plus 2a delta x, and plugged in all our givens. It starts at rest, so Vi is 0, 2 times you've just solved for your acceleration, and then 4 meters, because that's the height that block traveled. So then you end up with the velocity final being 4.43 meters per second. So that's part A. So part B says that you're trying to find the height that block 2 ends at. So I started by solving for the total energy, which can be found by the potential energy of mass 1 when it's at the top here. So like when the equation starts, mass 1 is 4 meters above the ground and mass 2 is at height equals 0. So the only energy, because it's not moving, is in the potential energy of block 1. So m 5 kilograms, height 4 meters times 9.8 meters per second squared, and then you get 196 joules, which is total energy. And then you set total energy equal to the potential energy of mass 2 plus the kinetic energy of 1 right when mass 1 is about to hit the ground. So you end up with 196 joules equals mgh plus 1/2 mv squared. Then you get 196 joules equals 3 kilograms times 9.8 meters per second squared times height, which you're trying to solve for, plus 1/2 times 5 kilograms times the velocity that you just solved for, because the velocity of the two blocks will be the same because it's in the same system. So 4.43 meters per second squared, get 146.938 joules plus 3 kilogram equals 3 kilograms times 9.8 meters per second squared times height, which gives you a height of 5 meters. And that is part 2.